In this video, we're going to talk about the different types of triangle congruency theorems. So before we can talk about that, we have to talk about some important pieces of triangles that help us to identify which triangle congruency theorem to use. So the first important characteristic would be an included side. So an included side is exactly what it sounds like. So it is the side that's included between two angles. And so this would be an example of an included side. So I can see that I've got my two angles and I've got my side that is in between those two angles, and that is what is called my included side. An included angle is very similar. So it is an angle that's in between two sides. So I've got a side here, I've got a side here, and my angle is what is formed by those two sides meeting up. So we've talked about vertical angles before. So vertical angles are going to be congruent angles. Congruent meaning equal, so equal angles that are going to be across from each other when two lines cross. So here are my two lines, and so when my two lines cross, they create two angles, and because those angles are across from each other, then that means that they must be congruent or equal in size. And corresponding parts of triangles are going to be parts in the same location. In two different triangles. So we're going to use the congruent triangles shown to complete each of the following, and then use the marking or matching marks to show corresponding parts are congruent. So the corresponding sides, TS and what? So TS is going to be across from the vertex of my triangle. And so also keep in mind that T is like a right angle. And so if T is a right angle, I'm looking for the other angle over here that would also be a right angle. And so that means that U would correspond, angle U would correspond to angle T. And so then X would have to correspond with S. So corresponding angles, I'm looking for corresponding angles in this triangle. And so angle S, we've already said, would correspond to angle X because they are in the same place. So angle S and angle T are here, and we're looking for the included side, which would be ST. All right, we're going to move on to this triangle. So in this triangle, we're looking for corresponding sides, and we're looking at AB. So what corresponds to AB? So looking at, if I'm thinking about splitting these two triangles in this picture, it's not a very good picture, but splitting these two triangles in this picture into two parts, what would it look like? So this is angle A and angle B and angle D, and this would be angle B and angle D and angle C. So the corresponding to BD would be BD. I skipped number 4, so let me go back. Corresponding side to AB would have to be CB. And the corresponding angle for angle ADB would have to be angle CDB. Okay, so now we're going to move on into the different types of theorems that you would have. So you can prove whether triangles are congruent by the following methods. So the first one is side, side, side. So side, side, side is if we have only information about the sides. So if all the sides of a triangle are congruent to all the sides of another triangle, the two triangles are going to be congruent to each other. So what that means is if I had two triangles, and if I had information that this side was congruent to this side, and this side was congruent to this side, and this side was congruent to this side, then that means that I can prove that these two triangles are congruent to each other, which means exactly the same size, based on the fact that I know that each side individually is congruent to each other. Another way that I can prove that two triangles are congruent is through a method called side angle side. So this means that I have two sides and the included angle. So if I have two sides and the angle included and the included angle, in one triangle are congruent to two sides and the included angle of another triangle, then that means that I can prove that the two triangles are congruent. So essentially what that means is if I have this side is congruent to this side, and I have this side is congruent to this side, and I also know that this angle is congruent to this angle, then I can prove that these two triangles are congruent. Another method is angle side angle. So angle side angle means that I'm going to have two angles and the side that's included. So if two angles and the included side are congruent to two angles and the included side in another triangle, then the two triangles have to be congruent to each other. So what that would look like is if I knew this angle was congruent to this angle and this angle was congruent to this angle, and I know that this side is congruent to this side, then I could prove that these two triangles have to be congruent to each other based on angle side angle. Another method is angle angle side. So if I have two angles and I have the non-included side of a triangle, so non-included meaning just another side that was not in between those two angles, then I can say that if I have the two angles and the non-included side of a triangle that are congruent to two angles and the corresponding non-included side, this blank shouldn't be here, of another triangle, then the triangles have to be congruent to each other. So for example, if I have this angle is congruent to this angle, and I have this angle is congruent to this angle, and I have this side is congruent to this side. So notice that these are two angles. This is a side that is not in between these two angles. Same thing here. Then I can prove that these two triangles are congruent. Also notice that this side and this side were congruent. Remember, it says that they have to be corresponding, which means in the same location. So notice that that side, this side, and this side both, we said were congruent to each other. But notice that if I had said this side, and then instead of this one chosen this one, that would not be considered angle side, because I would have my mark on the side beside the angle with two congruency marks, and in this one, if I switched it to this, I would have, and I didn't have this one, I would have the side beside the angle with only one congruency mark. So it's real important that you make sure that your sides that you're saying are congruent are corresponding sides as well. Remember, corresponding means in the same location, but just in a different triangle. All right, another method is hypotenuse leg. Now, hypotenuse leg is only for right triangles. So, two right triangles are congruent if the hypotenuse and one corresponding leg are congruent in both triangles. So the first thing I have to look for is that they both have right angles. These both have right angles, so hypotenuse leg is a possibility. And so the hypotenuse, remember, is always the side across from the right angle. So if the hypotenuse in both of these is congruent to each other, and then the corresponding leg, so say this one and this one, I could prove that these two were congruent by hypotenuse leg. So you cannot prove congruency with angle, side, side, or with angle, angle, angle. Now, think about the abbreviations for these. Let's start with angle, angle, angle. So if I was abbreviating that one, it would be A. So that's AAA. AAA is a service that you call if your car breaks down. We don't want your car to break down, so we're not going to use AAA. So AAA will not work. If I think about the abbreviation for this one, remember we abbreviate with the first letters of each word. This would be angle, side, side. Now this word we cannot say in front of Miss Ferguson's grandmother. So we are not going to use this word, which means that we are not going to use this to prove congruency. That also means we can't do this backwards. So you can't say this word frontward or backwards when you're trying to prove triangles are congruent. Okay, so in the examples below, we're going to determine which postulate, which of the ways that we talked about can be used to prove that the triangles are congruent. And if it is not possible, you're going to write not possible. So when I'm looking at these triangles here, I can see for one that I've got these two triangles where I've got these angles that are across from each other. So I've got a side crossing a side, and so I have vertical angles there, which means that these two angles are congruent to each other. Now, based on this information, I only have information about one side and one angle. So because I only have information about one side and one angle for each triangle, then for this one I'm going to write not possible, because I want to have information about three things always. So you're looking for three pieces of information. Alright, so whenever I look at number 5, I can see that this angle is a right angle. I also know that this angle has to be a right angle because that forms a straight line. And so straight lines are 180 degrees. So if this one's 90, this one's also 90. So I've got a 90-degree angle. That's one piece of information. I have information about corresponding side here. And because I do know that this is not just any side, let's call it by its name because it is a right triangle. So I have information about a leg. And then I see that I also have information about these two sides because these two sides are congruent. They're across from the right angle, which means that they're hypotenuse. So I have three pieces of information. I have a 90-degree angle, that I have a leg, and I have a hypotenuse. So the way that we would prove that these two triangles were congruent, we could say that these two were congruent by using hypotenuse leg. And you can abbreviate that as HL. Okay, when I look at number 6, I see that I have these two triangles here, and I notice that they share this side. Now, if I thought about taking this shape and splitting it up into two pieces, I would notice that this side is congruent to this, or this side, and let's see, this side and this side and this side are congruent. That's true. But I notice that they share that side. So if they share that side, so let's say this is A, B, C, and then that means that this would be A, B, and D. So if I split that up, let me do that here too. So A, C, and B, and let's make this D. So if I split that up, notice that A and B, so side AB, shows up in both triangles. That means that that side is congruent to itself. So that means that anytime that they share a side like that, we can always say that line is congruent to itself. So notice that when I look at that picture, I see that there is only, this line only has, like, I don't see how these match up. I can say this side's congruent to this side, and this side is congruent to this side. This side's not going to have a side that shows up to be congruent on that picture. But if I split it up this way, I would see that I had two sides that were congruent there. So I have information about a side in my first hash marks here. I have information about another side in my second hash marks there. And then I have information about this side that they share. And so I have information about three sides. If I have information about three sides, I can prove that those two triangles are congruent by something called side, side, side. Okay, so in example 7, when I'm looking at example 7, I see that these two triangles are across from each other by, and they're created by a line that intersected a line, and so that creates vertical angles, which means that this angle is congruent to this angle. Now I put those 2 marks on both of those angles because these angles already have those marks. Alright, so I noticed that I have information about an angle. That's my first ones. I have information about an angle, my second ones, and then I have information about a side. So I have 3 pieces of information, which is good. I have angle, angle, side. Alright, and number 8, these 2 triangles I could split up into 2 pieces because they're 2 separate triangles, but whenever I do that, I would see that they shared BD. So if I split that up into 2 pieces, this is A and B and D, and this is B and D and C, I could see that they share B and D, which means that BD is going to be congruent to itself. Now, on this one, I have information about an angle and a side and a side. Now, notice that this angle is not in between these 2 sides. It is an angle and then a side and then a side. So, think about what my abbreviation would be. This is not one that I can have. So this one is not possible because I can't prove that 2 triangles are congruent by ASS. Alright, then looking at example 9, I see that these 2 triangles share this side here, which means that this side is congruent to itself. But notice that I only have 2 pieces of information. I've got information about 2 angles that are congruent. I've got information about 2 sides that are congruent. But remember, I need 3 pieces of information in order to be able to prove that 2 triangles are congruent. So this one is also going to be not possible.